Dear students, let us begin today's session, day 2 on microcontroller. In previous class, we have covered with the different addressing modes of 8051. Briefly summarize the addressing modes. Immediate addressing mode, in which data is a part of instruction. It is preceded with the hash. Register addressing mode, both the operands are registers. Direct addressing mode, one of the operand will be memory location. In indirect addressing mode, data pointed by registers R0, R1 or DPTR. In relative, absolute, long and index addressing modes are used along with jump instruction to a specific location, which it may be between -128 to 127 or below 2 kilo or between range 0 to 64 kilo. For the today's session, I will start with 8051 data types and assembler directives of 8051. Let us begin first. Data type of 8051 defined with dB. dB defines 8 bits in which data can be declared with decimal, binary, hexadecimal or ASCII. If the number represented with decimal, followed by D. If the number represented with binary, it is followed with capital B or small b. For hexadecimal, represented with H. By default, if number is not represented with any, it is considered as a decimal. And one more note, regardless of the number what we are represented, all will be converted into hexadecimal. Next, ASCII characters are represented in double quotes. Let us take example 23. Its equivalent ASCII value will be stored into memory location. Correspondingly, set of characters hello, it is represented in a characters HELLO. Each character will be stored in its equivalent ASCII value. For example, if H will be stored in a location 2000, next character will be stored in 2001, 2002, 2003, 2004, like this. Let us take with the example here for a simple program to understand about how to use a DB. My program will be started with at the location 5000. The next instruction data 1 is a label with a colon space db 28, means 28 is a decimal value. It is stored in a location called data 1. I hope you understood. 28 is stored in a location data 1. Just previous to this one, my program begins at the location 5000, means this corresponding data 1 will be assigned for the location 5000. The next instruction data 2 db binary bits, means this binary bits is stored in a location data 2. Similarly, it has got a memory location of 5001. Next line data 3 db space 39h, means 39h is a data stored in a memory location. Let us consider how do we use with ASCII values. My program will be given with the origin 5000h. The next instruction DATA4 is a label colon space DB 2591. 2591 is a ASCII value. It will be stored in a label data4. Next one, data 5 colon DB in double quotes welcome. It is a set of characters. W will be stored in a location. Let us say my previous instruction will be begins at the location 5000. Next data 5 will be begins at the location 5001. Means at the location 5001 W is stored. 5002 E will be stored. 5003 L will be stored. 5004 C, like this. And remember this, each character's ASCII value will be stored. Next we'll go for assembler directives of 8051. Assembler directives are supported with ORG, EQU, END. Let us take with ORG. It indicates beginning of the address. I hope you remember in our laboratory we have started each program with the origin 000H, means my successive program will be started from the location 00H. Here I have mentioned with 5000H, means your program will be begins at the location 5000H. It indicates a beginning of the program. EQU, it to define constant without occupying memory location. EQU to define constant without occupying a memory location. It means it will give a storage space for any assigned data with a label, corresponding label. For example, count EQU is 25, means 25 is a data, it will be stored or it will be labeled with the COUNT. If in further in my program, if I want to use 25, we have to use with its corresponding label. It will be as good like COUNT is equal to 25H, means 25 is stored in a variable. Further in my program, if I want to use, we have to use with the COUNT. Okay, let us take in the next instruction, hash count, means the count value will be 25. 25 is loaded into register R3. Next assembler directive END, it indicates end of the assembly code, means any program written after the end will be ignored by the code. This is about the assembler directive of 8051. Next, the rules to be followed for labeling of assembly language. Let us take, if I want to label particular instruction, we need to follow the setup rules for labeling a name. The label name must be unique. They should not be the same name given for the multiple instruction line. Second one, label consists of alphabetic letters. It may be in uppercase or lowercase, or it is a mix of 0 to 9. And special characters are allowed. For example, question mark, dollar, dot, @ underscore are permitted to give with the labels. Remember, the first character of the label must be alphabetic character. It should not be start with any number. And the very important, reserved words cannot be used as a label. For example, moo. Moo is a reserved word. Add is a reserved word. We cannot use this as a label for a particular instruction. Now, instruction types of 8051 are divided into 5 functional groups: data transfer operations, arithmetic operations, logical operations, Boolean operations, program branching operations. Let us begin one by one. The very first one, data transfer operation. What do you mean by data transfer operation? Instruction tells to transfer a data between an internal RAM location or between the registers. And it is possible to transfer a data from external to internal, from internal to external, vice versa. This is a simple opcode for the MOV followed by two operands. The operands will be given with the destination byte, comma, source byte. This instruction tells to move a source byte into the destination location. This byte is not affected with any source. Neither are any other flags are affected with the move instructions. For example, move R1, hash 60 means 60 will be copied into R1 register. Move A, @R1 means data pointed by R1 will be copied into A. Next instruction, move R2, hash 61 means 61 will be copied into R2. If I follow for the add instruction, the content of accumulator will be added with data pointed by R2. Let us go back to the previous instruction. R2 will be loaded with 61 means R2 will be pointing at the memory location 61 means content of 61 will be added with the content of accumulator. Okay. The next instruction will be move R7, A means the content of accumulator will be copied into R7. This is the same example what we are given. After addition, the content of 60 we took as a 10H, content of 61 20H. After addition 10 plus 20, the result will be stored into accumulator, that is a 30H, and further it will be copied into R7. These are the set of operational instruction for the move, how we can use it. The first one, move A, hash data means hash is immediate data addressing mode. Let us take with the right side, we are given with the example. Move A, hash 35H means 35 is copied into accumulator A. As we know that the size of accumulator will be 8-bit. Next one, move A, Rn. I hope you can recall addressing mode of this is a direct addressing mode in which register content R0 to R7 will be copied into accumulator. For example, move A, R2 means content of R2 is copied into accumulator A. Move A, direct means the content of memory location will be copied into the accumulator. For example, move A, 30H means content of 30H is copied into accumulator A. For the next instruction, move A, @RI. I stands for I equal to 0 and 1 means we can use only specifically two registers R0 and R1. That is example, move A, @R1 means data pointed by R1 will be copied into accumulator A. Move Rn, A means content of accumulator will be copied into one of the registers. Move direct, A means content of accumulator is copied into the memory location 40H. Move @RI, A. In example, move @R0, A means content of accumulator will be copied data pointed by R0. Move Rn, hash immediate means immediate data will be copied into one of the R0 to R7 register. In this example, 34H is copied into register R2. Move Rn, A means content of accumulator is copied into R4 registers. Move Rn, direct means move R3, 40H means content of 40H is copied into R3. Move direct, hash data means immediate data 55 is copied into the memory location 30H. Move direct, @RI. In example, move data pointed by R0 is copied into the location 40H. Move direct, A means the content of accumulator is copied into the memory location 40H. Move direct, Rn means move content of R2 into the memory location 50H. Very interesting instruction. Move direct, direct means both operands are memory locations. For example, move 02, 03H means content of 03H is copied into 02H. As we have seen in a program in laboratory, we are used with the 02 is a memory address of register R2. 03 is a memory address of R3. Means I am copying from content of R3 to R2. Okay, just look in the previous way. We don't have like a direct copy from register to register. Means there is no supportive instruction for move to copy from R0 to R7. Move @RI, hash data means the immediate data 60H is copied at the memory location data pointed by R1. Move @RI, A means content of accumulator will be copied at the memory location pointed by R0. Move @RI, direct. In example, move @R1, 40H means content of 40H is copied at the memory location pointed by R1. Let us take with the 16-bit data loading operation. We have only one register for which we can use it to store with a 16-bit, that's a DPTR, in which remember it is also not affected with any of the flags. We know that the flags will be having 8 bits. None of the flags will be affected with move. For example, move DPTR, hash 1032 means 1032 is copied into the DPTR register. We know that DPTR consists of two registers, DPH and DPL. DPH is 8-bit, DPL is a 8-bit lower byte and higher byte, in which 10 will be copied in a register DPH, 32 will be copied into DPL register. Move C A, @A plus base register. Very interesting instruction. Move C means this instruction moves a code byte from program memory into the accumulator. Look at this. My destination is accumulator. Source will be, the address will be generated by addition of content of accumulator with base registers. Base register we can use with the PC or DPTR. For example, move DPTR, hash SQR. Let us take his hash SQR means SQR is a address for the data 0, 1, 2, 4, 9, 16, 25. Likewise, let us assume that my SQR is assigned with 1000 address. In the move DPTR, hash SQR means 1000 will be loaded into DPTR. I hope you understood. Okay? Like this. DPTR equal to 1000. Means 1000 will be loaded into DPTR. If I want to use move r3 comma hash 0 means r3 will be loaded with 0 0. Increment r3. R3 will be incremented by 1. Let us say 1. Move a comma r3 means what is the content of r3 will be 1. 1 will be copied into accumulator. Now accumulator will be 1. Okay. Move c a comma at the rate dptr. A plus dptr means what is the content of a? 0 1. 0 1 plus dptr. Dptr value will be 1000. 1000 plus 1 means it will fetch the content of 1001. What is the content of 1001? Is a 1. It will be loaded into accumulator. I hope you understood. Okay. If my content of accumulator will be 2, for example, 2, 2 plus 1000. What is the content of dptr? 1000. 2 plus 1000, 1002. 1002 means it will go to the location 1000, 1001, 1002. What will be stored in 1002? 2. 2 will be copied into accumulator. Means as good as we are copying from program memory into the accumulator. Or also this MOVC is supported with MOVC is also supported with the PC. For example, move a comma at the rate a plus pc means content of accumulator will be added with content of PC register. I hope you know that the PC is a 16-bit register. 16-bit plus accumulator will be added and the data pointed by this memory location will be copied into accumulator. Next instruction, move x destination byte comma source byte. Here x stands for data will be transferred from external memory. As we know that we have a two memory, internal memory and external memory. Provided if we want to access the data from external memory, we have to use with the x. Okay, let us take that internal memory is supported with 64 kilobyte and the extra 64 kilobyte which is coming from the outside memory and we want to access from the outside, for which we are using MOVX. Let us take with the example here. MOVX a comma at the rate dptr means dptr will be loaded with 16-bit address which will be from the external memory. Means data is coming from external memory and it will be copied into accumulator. For example, MOVX at the rate dptr comma a means my content of accumulator will be copied into the data pointed by the dptr. Means the data will be copied into the external memory location. Means vice versa, we can save the data from external memory to the internal memory a, that is the internal memory, that is my a accumulator register, from internal memory, that is from a to external memory. Both will be operatable for MOVX instruction. Also we can use with the R0 register also, provided we know that R0 or R1 are of 8 bit. This is the same example what I have given here. dptr, move dptr comma hash 1034 means 1034 will be copied into dptr. Means dptr is pointing at the location 1034 means data pointed by 1034 will be copied into a. Means 1034 it is not located inside the memory, it will be located at the external memory. Means it is available at the external memory. If I want to load, let us take dptr will be pointed at the location 1034. The content of 1034 is 77 and 78. 77 and 78. 1034. I want to copy from 1034 means content of 1034 is 77 is copied into accumulator A. Next, push instruction. This instruction increments the stack pointer SP by 1. As we know that our stack pointer is supported with SP register, which is of 8-bit, and it is pointing at the location 07 by default, and it is supported with the instruction called push and pop. And one more very important is that these instructions are not affecting any of the flag register. For example, push 22 means the content of 22H is pushed onto the stack. Stack means what? The SP is pointing to the memory location. Which memory location it is pointing? By default 07 means SP will be incremented to 1, means now SP will be pointing to the location 8, means the content of 22 is copied into the 08 location, and after loading SP will be automatically incremented to the 1, means now SP will be pointed to the next location 09. Okay, the next instruction, if I give push 23, means what will be loaded? Content of 23H is loaded into the memory location 09H. I hope the point will be clear. Okay, now for example, what I given here 07 and the content of memory location 22, 23 are loaded are 11, 11 and 12, means 11, 1 is copied in location 8, 1, 2 is copied in location 09. Means if I give here push, means my stack will be getting incremented, means the top of the stack will be like a highest memory location where it is pointing. In my example, it is pointing at the location 09, means it is considered as a top of the stack. When the top of the stack, when I given here, okay, so it is to get back, to retrieve my data back, we are using with the pop instructions. This pop instruction, okay, it is also supported with a stack pointer. Now previously in my push, it is pointing into the top of the stack. Now top of the stack was 09. Now when I want to retrieve my data, let us take retrieve my data pop dph, means the content of top of the stack. What is that? In my previous example 09 will be copied into dph register. I hope you understood. Once the data will be retrieved, automatically SP will be decremented. In pop, the SP will be decremented. In push, the SP will be incremented. Okay. The next instruction is move DPL, means when SP is decremented, now it is pointing at the location 08. What is stored in 08? It is 11, 11. 11 will be copied into DPL, means my data are stored in two registers, DPH and DPL. Okay, after operation DPTR will be loaded into 1211. We can use any register. Let us take that pop R3, pop R2, means the top of the stack data, it will be copied into register R3. Okay, after this it will be decremented. Now the decremented memory location data will be loaded into R2 register. Okay, the next instruction XCH A comma byte. Okay, just observe it. In exchange, it is an operation called exchange. In this, the destination has to be always accumulator A, and the source can be byte, it can be register, it can be memory location, it can be @R0 or any addressing modes. We can use it. Okay, what is the operation of this exchange? It will just exchange the content of source byte to the accumulator and content of accumulator to the source byte. I hope you understood. It is an exchange of a data byte. Okay, for example, we take here the content of R0. Okay, for along with the instruction here XCHE xcha comma at the rate r0 means the data pointed by r0 it will be getting exchanged with the accumulator a. Okay, let us take r0 will be loaded with 2eh means it is pointing at the location 2eh and the content of 2eh will take as 76h. Okay, and a content of accumulator I have loaded with f3h means my accumulator is f3, my the content of memory location 2eh is 76h before execution of the instruction. After execution both the data will be getting swapped means 76 will be loaded into accumulator and f3h is loaded into 2eh. I hope you understood the operation of xch. Okay, let us take with us few examples related to xch. Okay, now xch a comma r3. I hope you know that the destination has to be always accumulator a, not any register. Source can be any register or a memory location. That is not a problem at all. Okay, but remember that the destination has to be accumulator a means the operation is restricted to perform only with respect to accumulator a means the first instruction here. Okay, the content of R3 is getting exchanged with the content of accumulator means content of accumulator will be loaded into R3, content of R3 will be loaded into A. Both are supposed to be 8-bit. The next one, the content of memory location 40h is getting swapped with accumulator A. The data pointed by R0, is exchanged with the content of accumulator A. The data pointed by R1 is exchanged with accumulator A. I hope exchange will be clear for you to understand. The next instruction is xchd is an opcode and it is also followed with the accumulator A at the rate ri. Okay, just cautious about this instruction. xchd exchange with accumulator A and the source byte what we are given at the rate, it is supposed to be the data pointed memory location means what the operation will be doing. This instruction exchanges the low order nibble of accumulator. I hope understood. Low order nibble of accumulator with that of the internal RAM location pointed by RI register. Okay, means what is meaning of this one? The content of accumulator, the lower 4 bits are getting exchanged with data pointed by RI, and that it is also supposed to be 4-bit only. Okay, and it is not affected with any of the flags. For example, let us take with the example here. Okay, xchd a comma at the rate r0 means what is the content of r0? 2eh. Okay, means the 2eh is considered as a memory location. What is the content of 2eh is f3h. I hope understood. Now what is the content of accumulator? 76h means content of accumulator is 76h. Content of memory location 2eh is f3h before execution of the operation. Okay, which is the lower nibble of the accumulator is 6, which is the lower nibble of a memory location 2h is 3 means only the lower nibbles are getting exchanged means after the execution of the xch, now accumulator will be loaded with 7.3 and content of memory location 2eh is loaded with f6. F6. Okay, let us take with the one more example here. A content of R0 is content of R0 is same 2EH will take, and 2EH will take as a AB, for example AB, and content of accumulator will be like 0 1 0 1. After execution, the content of accumulator will be 0B, and content of a 2EH will be like A1. I hope you understood. Okay, this is about the brief summary about the move instruction, how different way we can use it for the operation to move from source to destination. Okay, just briefly I'll discuss about this one. Move @ri comma direct means the data will be copied from memory location to the data pointed by ri, and the next one, move @ri comma hash data means the immediate data will be copied at the data pointed by ri. The third one, move dptr comma hash 16-bit data. If I use a dptr is a 16-bit means 16-bit data is copied into the register dptr. Move C. I hope you understood what you mean by C. C for code memory. Now data pointed by A plus dptr means the memory address what is generated after addition of accumulator A and dptr is copied into accumulator. Move C A comma @A plus C means data pointed by A plus PC will be copied into accumulator A. The next one, move X A comma @ri data copy from external memory which is pointed by ri into the A. Similarly, data pointed by dptr, that is from external memory, it is copied into accumulator A. Move X, content of accumulator A is copied into the data pointed by ri. Content of accumulator will be copied into the data pointed by dptr. Push, it will push onto the stack. Pop, it will retrieve the data from the stack. Exchange, XCHD, it will getting exchanged with the content of accumulator. It may be register or it may be a memory location, provided destination will be compulsorily accumulator. XCHD, the content of lower nibble of accumulator will be getting exchanged with lower nibble of data pointed by ri. ri means it may be R0 or R1. Dear students, I hope you understood how to use a move instruction for today's session. For and one more very important is that the use of move, particularly with the 8-bit and the corresponding register. Careful about this one. Okay, so you may end up with like any error. Okay, so careful that how do we use the registers for the corresponding move instructions. I hope you understood the operation of move for the today's session. We'll meet in next hour to come up with next instruction, that is the arithmetic instructions. Thank you.